Well, thank you for this introduction. Excellent. So I got the slide here. And thank you for being here in this sunny afternoon. My name is Marc-Andre Cossette. I am an artist and a Ph.D. candidate at Concordia University in Canada. So actually, in my artistic practice, I incorporate actually live performances with artificial neural network, well, in various configuration. And it is actually the main topic of the talk today, which is the configuration of human action and artificial generative processes in performance specifically. So the talk is named Creating with Artificial Neural Networks from Micro Generation to Real-Time Composition Agents. So in other words, my objective is not necessarily to propose what true or false in terms of artistic creation, but to reflect on the role of human and artificial processes. In other words, what form of structure, can emerge out of artificial and biological neural network behavior, and what happens when they meet essentially on stage in front of people. So I'll use some of my work in solo and also in collaboration to define a practice that I call microgeneration. And then I'll turn to my current research on the idea of compositional agents that essentially reverses the role of the human artist and the artificial agent. For that, I'll use the example of a performance in progress that I'll show you where we are. It's not done. It's really a work in progress. But I'll try to identify basically where the shift happened in the configuration of the human and the artificial agents. Before I get into my work, though, I want to talk about two composers that I've drawn from in developing my practice, and that essentially started with generative music. So some of them you might know, and well, we're going to start there, and then we'll go on in my work. I think they provide a good background. All right. So the first is, of course, composer John Cage, whose influence basically is the first to introduce chance operation in musical composition. So he's a composer. What we hear in the background is Dream from 1948. And also, as you see in my presentation, I work a lot with dancers. So I think it's important to acknowledge Cage's work with Merce Cunningham and introducing chance operation in choreography as well. So in many of Cage's pieces, Cage would leave to chance micro elements in his piece, like, for example, the individual sounds, and then actually organize them and compose them in time. One good example, and it's a famous piece by John Cage, is 4-Minute 33 that you're probably familiar with. Some of them refer to the piece as a silent piece. Essentially, it's a score with no notes. So all the sounds that occur in the piece are left to chance. So the whisper of the audience, some laughing, coughing, the sound in the room. But those sounds are actually organized in time. They're composed into movements that are marked by the opening and closing of the piano. Another example of the use of chance for micro sounds is the piece Water Walk that was composed in 1960. So in Water Walk, Cage has a bunch of household appliances. He has a water pitcher, he has a bathtub, and what he does, he manipulates those objects that actually produce sounds. Each individual sounds are actually left to chance, but each action is precisely timed in space following a mathematical function. So each action is precisely timed. He has a stopwatch, and he performs these actions precisely in time to follow the composition. So that's an interesting approach that I use in my work in terms of leaving some of those micro elements up to the generative processes and then organizing them in time. All right. So we're going to go to the next composer, which is Brian Eno. Again, that you might be familiar with, famous composer of ambient music. So precisely, I want to talk about this album, which is called Generative Music 1, that was published in 1996 on floppy disk. So some of you might not be familiar with floppy disk. These were 1.44 megabytes storage device for computers. So this album actually came with the, I'm gonna put down the volume a little bit. There you go. This album actually came with the SSCO Koan software, which actually, when the user ran each program file, the pieces would generate themselves. So with this specific album, the system actually used probabilities that were encoded by Brian Eno to generate individual notes on the pieces. And then all these streams of notes that were generated were organized into movement, into individual tracks to compose this album. An interesting fact about this album is that it does not actually contain music. So the album actually contains instructions to play the music. And these instructions are actually played via the MIDI protocol on the onboard synths of the user, which actually is super interesting because the disc doesn't have to contain audio. It can be super light, and also, depending on the machine you play it on, it sounds slightly different. Okay, so this is also a process that I use in my work. Is actually not necessarily generating music itself, but generating instructions to play music. So this leads me to this idea of microgeneration. So what I mean by microgeneration, I mean processes used for generating elements in the smaller time units, so the micro, to be organized or arranged by the composer over larger time units, macro. Okay, so in other words, organizing them over the performance, the duration of the piece. So in 2017, 2018, I started using this method of microgeneration to create generative music using a small neural networks that was trained using unsupervised machine learning. So basically, the data that I gave my neural network were not labeled, so the neural network actually organized the data itself. And that gave us the Project Gray area that was created in 2018. Actually, I performed in 2018 in a residency at the Centro Mexicano para la Música y las Artes Sonoras, CMMAS, in Mexico. And for this creation, actually, I generated individual music notes, as I said, using a small neural net architecture. And this would actually learn automatically from existing human composition. So I ran scores through this neural network as training data. And basically, the network was tasked to identify pitches in the scores that were related in time, so that were kind of closer together in the composition. And then once trained, that network was actually able to predict the most probable note in the sequence. So by layering generators that were trained on the same data, there's a kind of tonal drift that happens, meaning that they have the exact same data, but they don't predict the exact same thing. So what happens when you layer 10 or 15 generators into different synthesizer is that basically it creates some phrases, some progressions, some chords that remains tonally coherent because they were trained on the same data, but that go into different direction. So all the pieces, so there's 12 or 13 pieces in that project, were actually all recorded live. Essentially, I ran the neural nets and I was mixing live the different data streams into synthesizers and recording the results. So there was no editing into what was generated. So everything was essentially a captured performance. So you can kind of feel the influence between Cage and Eno in the early work that I did. All right. So following this project in 2019, actually, started working with dancer and choreographer Myriam Arsenault-Gagnon in the interactive dance piece that was called Altérité numérique, roughly translated to digital otherness. So in this piece, put some volume. There you go. In this piece, I used essentially the same technique for generating the music. However, I added a small neural network that actually tried to recognize the specific form of movement and then select the configuration of instruments, and also apply some mapping between the sensors that were on Myriam's body and the sound to add a little bit of a reactive component to the sound. So this work is actually questioning how the performer can improvise with the generative neural net and form a sort of conversation with the generative media and the performance. It actually played on the uncertainty of the system and the need actually to explore how music would evolve from a particular improvisation. How we can actually create emergent phenomena instead of choreographed events inside the performance. So everything that Myriam was doing was completely improvised. So we worked in the studio through some generation improvisation to generate ideas of movements and also compose with the sounds that were generated and the melodies that were generated by the system. So this idea of performing with neural network and generated processes is something that actually remained with me up to this date in the work that I do. Each of the work is kind of an attempt at a configuration of a human-machine performance. And so as I said, the generation for this piece was very similar to the prior one. And again, we're in that format of micro-generation where the pieces, the individual notes are generated by the algorithm while the whole piece over the duration, the larger time frame, is actually organized here by the artist. Here it was by the actual movement of the performer. All right, so what do I have? All right, so here, 2020, 2021, we moved a little bit away from neural net. I started working with Alexandre Saunier in a duo called ALMA, and so we started exploring that stochastic process called Markov chains. Simply put, Markov chains are algorithms that are based on example sequences to determine the probability of the next event based on the current event. So what we did is we crafted a bunch of example series based on tonal chord progressions, fed them to the Markov chains, and then layered Markov chains into synthesizers to create the music. So let me put some volume here so we can hear. So for this performance, we also generated 3D models from video images using photogrammetry. So these models were then actually placed in space in a 3D engine, in a game engine for exploration during the performance with the music. So once again here, and the name says it, we're into micro-generation. We're interested in generating fragments, small units that we then on stage organize live with the audience. That's another quick example of another configuration. It's called Fluid Dynamic. That was from 2021. Basically, another use of Markov chain and improvisation. in this performance, it's a little bit different because there's two sides to the performance. So first of all, there's this idea of organizing all the data that is generated by the neural nets in the Markov chain, in real time. So that's what I'm doing on one side, and Alexandre Saunier is actually improvising with the guitar on top of what's being generated, trying to follow the generation by the stochastic processes. And we actually use the name fluid dynamic, in this case, dynamic referring to the dynamic between human and machines. So yes, that was a more post-rock performance. All right, so, got time. All right, following, in 2022, we got back to work with Dancer, with the duo ALMA, and we collaborated with choreographer Axel Munizero and two Montreal street dancers to create the video work named Restless. That's part of a research creation project called Granular Movement. So in this project, actually, we focused on the process of granulation in sound synthesis. This is a technique of taking small units of sounds and recreating tones with them by repeating them over and over again. Now, we decided to try to apply this principle to movement, to choreography, and to inspired by actually the concept of freestyle in street dance. So to do this project, we started by motion capture some freestyles from Dancer in Montreal, and then the choreographer would act in real time on the choreography while we did the generative music performance. So like in Fragments, the focus and the thematic was on small elements, in this case, grains. So these grains are, as I said, the small units in time that we can manipulate, repeat, shuffle to recreate new elements from existing recordings. So, and similar to the first album that I talked about, this video, so the Restless video that was shown at the ELEKTRA 2022 Biennale in Montreal, was recorded from that live improvisation. So everything is live, there's no further editing. The music is done live, and then the video is done also live with the music. So we're going to stay into 3D animation with the next project. So that was last year, 2023, called Groundless. This is, again, a collaboration with Alexandre Saunier, and this time with artist and researcher Paloma Layton, who's a circus artist and researcher. And so basically our approach for this piece was quite different, though. So I'll put up some music so you can actually hear the difference. First of all, the music is not generative. So for this piece, the music was completely recorded on acoustic instruments, the handpan, the ronroco with Alexandre Saunier. So we decided to shift to an aesthetic that is less electronic and more acoustic. In terms of the choreography, Paloma Layton was actually creating the choreography in improvisation session with the music. So there was a kind of collaborative creation that was done. And so once we had the music and the choreography, we realized some mocap session to capture the animations. And these animations and the way they're presented, so camera angles, the model that they were, that is represented on screen, and also some changes in the movement, is manipulated by a type of neural network called spiking neural network. So spike neural network have this particularity of being able to adapt to time. Which is interesting because instead of adapting to data by generating specific data, they adapt to rhythm and what we call stimulation of the network. And what happens is that they end up doing those rhythmic pattern that can then be used in this case to give a visual rhythm to the image. So basically, the performative element is also quite strong in, quite present in groundless because those video recordings are, once again, the spike neural network acting live on the image and the result being captured as a video recording. So because of the temporal organization of the spike neural network and how their behavior can be perceived over time, I started actually to question the practice that I had of generating small elements and wondering how I can use those elements, those neural networks, to act over the time of the piece, and then what would be my role as an artist in this case. All right, so that brings me to this slide, rethinking human-machine configuration. So how can one use the neural network for generation on a larger time scale? So in this case, we're still generating camera angle, we're still generating changes that happen, but the changes can be perceived over time. Now, after working on groundless, as I said, I started questioning my role as a human artist and also what I was delegating to the neural networks. So I wanted to change a little bit that practice and see how the neural net could work on a larger time scale as compositional agents. And also, well, what would be left of me? What would I have left to do in those in these works? So before getting into creation, I did some research onto what form of neural network can actually use live streams of data and adapt their behavior from changes in that data. So I started to look at video game neural networks. So using a process here called reinforcement learning, I trained some agents to react in real time to incoming data. So in this case, they actually have some little sensors that they can track the course so they know what's ahead of them. So each agent then, this is what is called for the agent the observation space, and then they have an action space where they can act in space, in this case, move and jump. So from there, well, we can develop what we call the reward function, which essentially gives good and bad feedback to the agent. So, and the closer the agent gets to the goal, the better feedback he gets, and actions that don't get it closer to the goal gets negative feedback. So, simply put, the process actually reinforces the behavior that gets them closer to the goal, in this case, the yellow wall. Now, in this experiment I ran, it's very, very simple agents, and when they start, they don't even know which way to go. However, what I realized is that when I have an unperfectly trained network, in this case, I think agents were trained for like half an hour, something very, very light. On a small network, they all take different decisions because they're not perfectly optimized for the reward. So some of them jump over the gap, some of them fall in the gap, try to jump out, and it creates that form of distribution over the course. So that actually inspired me to say, how can I use this variation in decisions into performance and for creating artworks? So these are other tests that I have ran using the process called proximal policy optimization. So essentially, same process, there's a reward function. But in these examples, so the agent tried to optimize that reward function, but again, they're not perfectly trained. On the left, you can see agents go from searching behavior, the little guys there. So they do searching behavior, trying to locate the green ball in their field of vision. Once once they get it, you just run through it, but it doesn't always happen at the same time. So there's like a lot of variation on when that happens. And on the right, so you have the car driving the course, but each car will take slightly different actions to complete the course. And you can see when the camera turns away, there's a big crash happening, and every car will take a different form of action to try to avoid that crash. So again, these are imperfect agents that have interesting behavior. If they were perfect agents, they would all drive the course perfectly. And actually, since the objective is to do art and we cannot really optimize art, I was actually thinking, let's use imperfect agents and then try to push those variation in behavior as much as possible so we can actually create some interesting emerging phenomena in performance. All right. And this is where basically the idea for the project Ab Initio comes from. So Ab Initio is a project that I designed with Alexandre Saunier, Paloma Leighton, and light designer Bastien Miranda. And this project, as I said, is still in progress. We're going to see a little bit of a research and development phase with the neural nets, but it is an attempt to actually conceptualize the integration of compositional agents to a live performance. Simply put, an agent observes the movement of the live performance here using an array of IMU, so inertial motion unit sensors, that gives velocity and rotation of parts of the body. So this is the agent's observation space. And then it is tasked to making decisions in terms of what to play in terms of music, what lights to turn on, etc., etc. So the agent's decision on light and music will then affect the movement, affect how the performance unfolds. And this should basically, the idea is that this changes in the choreography will trigger new changes in the music, and so on and so on. So the idea is to amplify the variation in the agent's decision to form a sort of positive feedback for the agent to deviate from his training data. Now, the question is, well, if the artificial agent is making the decision on the music and the lights, what's our role as the human? Well, the strategy we have adopted for this particular project is to start composing in small units. So earlier in my work, I would leave the agent to generate the smaller units and then organize them over time. And in this case, what I did is basically say, well, let's compose smaller units of music. Let's compose small phrases. Let's compose individual bars. Let's compose tones, and then let the agent organize these tones in real time during the performance, and then see what kind of structure evolves out of this. And it's the same idea for the lights, where the lights are basically, instead of being full scenes, they're partial scenes, individual light positions that can be assembled in real time by the agent. So we essentially reverse the process that I've been using for quite a few years now by actually generating ourselves microelements and leaving the larger timescale to the agent. So as I said earlier, we cannot optimize art. Art is not something that you optimize. So using the process of proximal policy optimization was not necessarily something that I wanted to start with. So instead of writing a reward function, a goal that the agent would have, I actually started using imitation learning as an initial training process. So imitation learning is a little bit different. Instead of giving it a goal and explore and giving it a reward, you actually give the agent a bunch of example data of this is how you should play in these situations, this is how you should act in this situation. And then following new situation, the agent tries to figure out what it should do at this point. So here we have a little test that we're running at the moment. So what we're seeing here is of course, a 3D animation. And I need to mention that working with a live person in suspension is not easy. It requires a lot of equipment, a lot of security concerns. So in order to do our tests and train our agents, what we did is we booked a studio so we could realize motion capture of improvisation in suspension with the performer. Then in Game Engine, what I did is I simulated IMU sensors on the body to give the agent an observation space. So that way I can set up a kind of virtual gym for the neural net to be trained. And then once we have a working system, we can go back in the studio and then try it. So what you see here with the velocity and the rotation, these are the data from the virtual sensors. And then you can see at the bottom the little recording from Ableton Live. The clips changing are the decisions that are made in real time by the neural net. So in this case, again, it is very much imperfect. It's probably trained on 15 minutes of data, so very few data that is training it. And when I ran the inference, however, what's interesting is that it picks up configuration that were not in the example data. So already that gives us hope that what will happen when we have more and more music, when we have lights, when we have live interaction with the performer, that new configuration of music, of lights will emerge, and that should trigger also new form of improvisation on stage. And also working with those smaller units and composing them, what's interesting is that we can actually go to a more acoustic aesthetic. We don't have to stay in synthesizer world like in the previous iteration. So that's something musically that I wanted to do for a long time. And this way of working actually allows to go to a more acoustic aesthetic in terms of sound. So, all right, what's next for this project? Essentially, as I said, this is a project in development. First, well, we need much more training data. So we will in the next year, hopefully, organize new sessions in studio so we can actually jam with the performer live and record more training data for imitation learning. So it is based on human jam. So actually the idea is to give a human feel also to the decision that the neural nets will give. Then, of course, we'll need to increase the size of our neural net architecture. Right now, it's a very simple architecture. It has a couple hidden layers. It takes very simple decision. It has about 100 different music clips that you can choose from. When we get to about 1,000 music clips that you can choose from over a performance of 45 minutes, that will require some more complex decision making. So, of course, increasing the neural net size will be necessary. On the creation side, of course, composing more building blocks, so more music. So we're at the initial phase of this project, but the initial tests actually are very interesting and are very encouraging to basically pursue that direction, to have more variety in terms of music composition that can be played live by our composition agent. And finally, integrate lights and work with the choreography. Again, working with choreography and working with improvisation by composing smaller movement units. And then these movement units can be rehearsed and performed safely on stage with the neural nets. Now, just want to conclude. So this project, as I said, is opening new ways of working with generative processes and neural network as compositional agent. This is something I'm really interested in, and I'm interested to see what it will change in terms of process and what kind of aesthetic can emerge out of it. So when working with neural network, and again, I always question the nature of the work of the artist and what is delegated to the neural network. And this is a new configuration that this allows me to explore and hopefully leads to new form of artwork, new forms of performances. Now, from the practice, of microgeneration that I had developed in the past 5 or 6 years to using the live agents. So this changed, again, that configuration of human and algorithmic processes. I'm actually very excited to see what will come out of this in the following months. We're working actually to find a partner in Montreal in the circus and dance scene to put that performance together and to finish, again, this is by no means the only way to work with neural network over time in performance. But beyond, this is one way of exploring new configuration between the human and the algorithm. So I hope that these reflections overall can echo your own way of interacting and interfacing with artificial intelligence at large, and basically encourage you to explore the intersection of our behavior as biological being and the behavior of these artificial neural network. So, thank you.